All right, I told you yesterday that I will likely not be, excuse me, that I'll likely not be in class today. I've already called for a sub to kind of get us prompt or started. I wanted to let you know, let's go the other way. I wanted to let you know that I'm going to be moving fairly fast through this to keep the video short, so the size remains small. However, if you need the sub to push pause, just ask them to push pause and I'm sure they'll be happy to do it. So today we're going to be talking about the rate of change. We're going to calculate the rate of change and start values. Okay? The change in y values over the change in x values, usually with the denominator value of 1. Later in another lesson, I think about 2.8, we will know this as slope. We call that the rate of change. It will not always have a denominator with 1. If it's just comparing two different units, one over the other, it's just called a rate. And we'll get examples here shortly. So far, we've been calling rate of change the operation. Okay, we've been able to identify the operation because our inputs have increased by only 1. So we can see how much it's either going up or down. But what if we are given information that is not so clean? What if our only inputs go up by 2 or 3 or 4, or they go up in quantities that are not consistent? Well, we can still do something about that. We can calculate the rate of change, ROC, I'm shrinking it to rate of change, by the formula M. If you remember the other day, I told you M is the slope, and the slope will come in lesson 2.8, but for the moment, I just want you to get used to this, is delta y over delta x. This symbol in math means change in. Okay? So the change in y over the change in x. We typically read it from left to right. So if we were to plot a input-output table and we're reading it from left to right, if the delta y is going up, we've got a positive rate of change or a positive slope. If it's going down, as we read from left and right, it's going down in the negative direction, so it's going down. Remember that direction matters. Left to right, is positive. Down to up is also positive. So if it went from up to down, it would be negative number. If you're reading it from right to left, which you typically wouldn't do, but that also is in the negative direction. Think number line. Let's take a look at this equation. Slope equals delta y over delta x. The rate of change will always have the dependent variable, and we learned about that yesterday, in the numerator, which the dependent variable is our y value, is the second, the number in the second column, is the one that changes based on whatever was put into the formula. And the formula will come into play in section 2.8. And the independent variable is in the denominator. So let's take a look. Calculate the ROC, the rate of change. If Jessica loses, we're also going to do the start value and the operation, or the operation is the rate of change. Jessica loses 580 in 20 days in the stock market. So she loses 580 in 20 days. If things go the direction they're going, she's going to lose more than 580 in 30 days, if things go in the direction that they're currently going. So she is moving in the negative direction. She's losing 580 in how many days? 20 days. But up here we said usually the denominator value is 1. So we just do the division. That equals an ROC. I can divide by 10 top and bottom. That wipes out the 0. And negative 58 divided by 2 is negative 2, carry the 1, 29. So the rate of change is for every one we're going over, for every day we're going over, Jessica is losing $29 in the stock market. Stanley earned $53. $53. I don't know why that's there. For delivering 10 packages. How much did he make per package? Well, if delta Y is a plus $53 over how many packages? 10 packages. And we want the denominator to be 1, so we just do the division. And if we're dividing by 10, we're just moving that decimal over to 1. So it's $5 and the $5.3 or $5.30 per package. This plus $5.30 is the rate of change. It's also the operation. What's the starting value? You know what? It didn't give us a starting value, so we're going to ignore that for the moment. Let's take a look at the next one. What is the starting value? The starting value, remember a couple days ago, I didn't like how they called it the starting value because I want you to get used to using the term the y-intercept. The y-intercept, or the SB, is when x equals 0. Well, when does x equal 0? The starting value, y is at 17, so the starting value is 17. From 0 to 1, we're going down 2. So the operation is in the negative direction, negative 2. 1, my negative 2, negative 2, negative 2, negative 2, negative 2. So that's pretty easy. You were doing that in the homework last night. The rate of change, because we know the operation, is minus 2. Go and turn it over. What if it is not so clean? Let's consider the rate of change. Do you see my x values? I went plus 3 from negative 2 to 1. I went plus 1 from 1 to 2. I went plus 2 from 2 to 4, and I did plus 1 to 4 to 5. So I can kind of figure out the rate of change here. I went from 29 to 34, so I have a plus 5. And then we take a look at another place that I have the delta x, or the change in x is 1, and I've got a 4 to 5 here, and I have a plus 5. So I've confirmed that confirmed that our rate of change is plus 5, and that our operation is plus 5. Same thing. But how about our starting value? Well, it's when x equals 0. Well, if we're going plus 5 and 1 puts us at 29, then we can subtract 5, and it's going to be 24 when x equals 0. Because we have 29, our rate of change is plus 5, but we're going in the negative direction from 1 to 0, so we have to reverse the rate of change to minus 5 for it to be. Let's see if that works out. What if we went to negative 1? It would be 20. Nope, it would be 19. What if we went to negative 2? It would be 14. 19 to 14 with the plus 5. All right, last example. What if there are not two independent variables whose difference is 1? I have a plus 2 here. I have a plus 1 here. I have a plus 3 here. And I have a plus 2 here. So I can't really confirm. We can use the equation, the change in our y value over the change in our x value. Well, let's go ahead and do from 1 to 7. What is the change as we go from x equals 1 to x equals 7? Well, our change is plus 6. And what is our change here? 1 to negative 53. Well, what is that? From 1 to negative 53, we're going in the negative direction, 54. The negative divided by a positive is negative. 54 divided by 6 is negative 9. So our rate of change is negative 9. What about going from negative 1 to 0? Well, if we go from negative 1 to 0, we're going from 19 to negative minus 9 is 10. So our start value is 10. That's it. I want you to start getting, remember that I'm using the word slope. And then when I'm using start value, I'm using the word y-intercept. Because next week when we get to 2.8, that is going to be what you're using for the rest of your mathematical career. Have a good day. Oh, I will be collecting and grading the assignments when I return.